In this video, I'm going to chat about coaxial position tolerance, something I've never talked about in any real videos before, I don't think. So here we're going to start, we've got a block where the bottom plane is A, and the plane and a right angle to it is B. Now, we only need two datums here because the axis of this hole is parallel to these two datums. It's not at a right angle to it. So there's no reason to have C. C would have to be here. It doesn't matter, right? If we're already controlled in rotation to A and B, no need, there's no more rotational degrees of freedom to control. So that's why we're AB. Now we're starting with a single hole, and I'm going to split this and show it as two in a minute. We're going to have a 1/2 inch tolerance zone. I know ridiculously large, but it's easier for me to draw. So look something like this, right? 1/2 inch tolerance zone. Now we've got to prove that the axis of the unrelated actual mating envelope of this hole is within that tolerance zone that goes the full length, depth, and breadth of the feature, right? No real problem there. So what happens when we split this into two holes? Right, so I'm going to put a big cut in that block. We've got two separate holes. We've gone 2 times, 2 times, 2 times. So we repeated all of our dimensions and tolerances. The tolerance zone can only exist within the feature, right? So this tolerance zone goes to here, this tolerance zone goes to here. But really, not that much is going to change as far as your tolerance zone, right? They're both to A and B, so it's not like they're moving around or anything. It just doesn't go the whole length. Now the issue you can run into is when we had this entire tolerance zone, say we start here and end here with an axis, right? You can see we've got an orientation control there. If we start here and end here in the smaller tolerance zone, you can see we might have an issue, right? So the holes, the tolerance zones don't change, but because the length changes, we have a potential problem. So how do we solve that? Well, what we're trying to get across to the reader of the drawing is that these two holes need to be considered together, right? You want to say, hey, drill them together, line bore or whatever. Don't drill this side and then drill this side. So we can accomplish that with adding a second frame, right? And I forgot what it's called. This is a pattern locating something, this is a feature locating something, but I just say top or bottom, right? Top, bottom, okay? So on the bottom, we've got no datum reference. But because it's position, you consider those holes as a pattern, whether it's two holes, drilled into a plate, or two holes that are coaxial with each other. They are in a pattern. Those two tolerance zones essentially become one tolerance zone. So what we're saying here is that this point 2 is unrestricted, right? It can float around in those larger tolerance zones, but it's continuous, right? So when we go, when they make the part, they're going to look at this and say, hey, we need to make those two holes together. And then they can decide, because they have a larger number up here to A to B, how much time they want to spend indicating the part in. The making the two holes this smaller number is the easy part generally, if you're going to do them at the same time. You just line the part up and kind of go. That's just going to happen. Now, if you've flipped through Y14.5, you've seen an example like this where A and B are repeated, right? So let's go through that. What if we repeat A? Right? A is this distance right here. But because it's composite position, we don't do translation in the lower feature control frame, just rotation. So what we're saying is this tolerance zone needs to be parallel to A, right? It can't do this anymore, right? So parallel to A, but to B, it can swing out, right? And they'll be coming out from the board. So we've got to be parallel to A, right, rotation, but B, right, which is the other side of the part, so if we're looking at it this way, B can still rotate within this 1/2 inch tolerance zone. Now this is the reason we can repeat B on this. If we repeat B, we're just controlling the rotation, but now to B as well as A. So now that tolerance zone has got to be parallel to A down here and parallel to B, but it's free to translate within that larger number. So I know I've heard from people this is confusing when they see this, because you can't do this with like a pattern of holes. It doesn't do anything. But with coaxial features, it can. The last thing I want to talk about, if you have holes that are different diameters, you can still do this. What you do, one way to do that is you're going to have a diameter for this hole, and then you're going to apply the feature control frame to one or the other, right? It doesn't, normally, well, actually not one or the other. You apply it to the outline of the hole, right? So the reader is forced to say, wait, where's the position? Where's the position? There's the position, right? Then it's going to apply to both. Now, sometimes you'll see a note that'll say 2 coaxial holes. I would probably recommend putting that in there just in case. But the meaning should be pretty clear right here. Okay, so that's it. Position, coaxial holes, composite. Not as bad, not as difficult as it looks. If you enjoyed the video, please like and subscribe. Leave a comment down below.